Well, good morning, Science 10s. I just wanted to provide a little bit of feedback for you here. Not everybody has submitted this assignment yet, but just so that you're not making errors on your summative, I wanted to go through this formative. So here we have molar mass. And so we learned this week about molar mass, and one of the common errors that students make is not having the correct formula. And so if you don't have the correct formula written down, then your molar mass won't be correct. So here's an example of a student who was asked for molar mass of fluorine gas. So this is what I'm betting they did, is they wrote down, here's their answer, 19. They said, okay, well, they just looked on the periodic table and they see 19.00, and they did a great job. They got the correct number of sig digs, and so they're probably wondering, well, why the heck isn't my answer correct? Why does Mrs. Ledeen have 38.00? Because fluorine gas is a diatomic element. And so this student hasn't memorized the diatomic elements. Because fluorine is F2, is 2 times 19.00, that's 38.00. And of course, we've got our 2 decimal places. We have our units of grams per mole. So I'm just reminding you that we talked about this ages ago, and I, have harped on it, saying you have to memorize these, and now you're seeing why. If you don't have them memorized, you're now making mistakes in balancing, and you're making mistakes in molar mass. So everything we've done in Science 10 chemistry has built up to this point. So here's a reminder of your diatomic and polyatomic elements: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and then the polyatomics: ozone, phosphorus, and sulfur. So again, you've been asked to memorize these. Now, couple of ways to remember them: the puck and the hockey stick. This number 7 here, these are the diatomics. Here's phosphorus and sulfur. And the reason why they're diatomic elements is because they're sharing electrons to complete their octet. So if we look at something like chlorine, and chlorine has 17 protons in its nucleus, and that means it has to have 17 electrons, right? And so remember back to when we did an atom and we had the number of protons, and we knew that that first energy level would have 2 electrons and then 8 electrons, and then that last outermost, the valence, that's got 7 electrons. And so when we're looking at a chlorine atom, that's not a full octet. So what does it do is, to get that extra electron that it needs, it can either gain an electron from a metal like sodium in an ionic compound, or it can share electrons. And here's an example here of chlorine gas. This is why it's Cl2, because we're sharing these 2 electrons. This chlorine has 7 electrons on the outer energy level, and this chlorine has 7 electrons. So these 2, they're sharing, and that forms what's called a covalent bond, and that's why it's a diatomic element. So all these nitrogen, oxygen, fluorine, chlorine, those guys are sharing electrons. So there's several ways of remembering this, as I have mentioned: the hockey stick. Here's another one: have no fear of ice cold beer, a little mnemonic to remember it, but you have to have these memorized. Okay, so here's another question that students got wrong, just to quickly go through this. Molar mass is number of moles per 1 gram. No, that's not correct. It's number of grams per 1 mole. So these words are not correct. They're mixed up. They're in the wrong order. Okay, so it's always grams per 1 mole. 1 mole is equal to 6.02 times 10 to the 23 grams. No, it's 6.02 times 10 to the 23 particles. 1 mole of carbon atoms has a mass of 14.01. No, if you look up on the periodic table, it's 12.01 grams for every 1 mole of carbon. So this value, 14.01, is for a nitrogen atom. And finally, oxygen. Well, so now look here. Good. You guys remembered this, that it is diatomic, and O2 is going to be 16 0.00 times 2, and that is 32 grams per mole. Okay, so the correct answer there would have been D. Okay, so another numerical response question here, and this one is on the molar mass of acetic acid. And I think where students went wrong, again, was not getting the correct formula. So just a reminder how to name acids. Well, we have these three different naming rules. And we see acetic acid is an ic acid, right? It ends in ic. And so then we know it's hydrogen something 8. And so we know that it's going to be one of our polyatomic ions from our chart. And so we know it's going to be hydrogen. And then we have to look up the 8 ending. So acetic means acetate. So we've got hydrogen and acetate ions, and we put them together and we get CH3COOH. Remember I said one way of recognizing that we have an acid is either an H at the beginning or a COOH at the end. And here's an example of one of these. This is an organic acid that has the COOH ending. So yeah, we've got CH3COOH, and I think that a lot of students made the error here. They forgot that H at the end, okay? They just had the acetate ion, but these acids always have to have either H at the beginning or the COOH at the end. Now then, once you have the correct formula, and that was the biggest step here, then you calculate the molar mass. So there's 2 carbons. You look up carbon on your periodic table and you're like, oh, well, that's 12.01. So 2 times 12.01. Plus there are 4 hydrogens. There are 3 here plus that one more. So we count up, there's 1, 2 carbons. There are 4 hydrogens, and how many O's? There are 2 O's. Okay, so we look up each of those on the periodic table, add them together, and then don't forget that your final answer, like every time we are writing molar mass, has to have 2 decimal places. So it's going to be 60.06, and that's what then you have to enter into the numerical. Okay, so 60 was not accepted. 59.0 something, not acceptable. You didn't calculate the right formula and you didn't calculate the molar mass. 60.05, you made an error in a calculation. Okay, so it has to be exactly 60.06 or you can't get that mark. Okay, so unit conversions, I'll just quickly go through a couple here. We've been given a number of moles and we're asked to find mass. So we use our molar mass as a conversion factor. So the most important step is that first step, and to make sure that you get the right formula. So it's calcium hydroxide. So I know that a lot of students forget to put that OH in brackets. And so if you write CaOH2, you're not going to get the correct molar mass. If you do it correctly, you get the molar mass of 74.10 grams per mole. There's 1 calcium, and this 2 is a multiplier. There's 2 oxygen. The 2 is a multiplier for the H, 2 hydrogens. If you didn't write the correct formula, you only get 1 oxygen, and therefore your molar mass is not going to be correct. So if you've gone and done the molar mass correctly, now you got to do the unit conversion. So we're given moles in the question. That's what we always start with. We've got moles on top, so we just use the molar mass normally, and moles go on bottom. So on your calculator, you just multiply 3.00 times 74.10. You get on your calculator 222.3. So now you got to go back to your question and you look and you say, okay, well, I've got 3 sig digs here, so my final answer has to have 3 sig digs. And the units, so I'm looking for mass, and I've canceled everything out except grams, so my final answer is 222 grams. Okay, so a couple other examples of mass to mole and mole to mass conversions. This one, we're given them grams to start and we're asked to find moles. So again, tin bracket 2 iodide. Well, first thing is we got to make sure we've got our correct formula, SNI2. We add up our elements to get a correct molar mass. Now for this one, we're given the molar mass, and our molar mass has 1, 2, 3, 4 sig digs. So I know my final answer has to have 4 sig digs. Now that I have this molar mass, I know that I can use that as a conversion factor. And in this case, because I'm starting with grams, I'll put grams on the bottom to cancel. And that will leave me with units of moles. So on my calculator, I take 204.9 times 1 divided by 372.51, or just strictly divide by 372.51. 0.51. So here's where I think that you made your error, and that was in sig digs. So you have to have 4 sig digs in your final answer. So this is what your calculator shows, but remember, your calculator doesn't do sig digs and it doesn't do units for you. So you have to go back and you have to round your answer, and you can have 4 sig digs. So 1, 2, 3, 4. Well, that 5 is going to make that round up, and so your answer is 0.5501 moles. Okay, so rounding and making sure that your answer is in the correct units. Okay, so here's another example. Given moles, find mass. Again, make sure you have your correct formula, Ag2CO3. Get your correct molar mass, and then your unit conversion. This one's easy because we just use grams per mole as is. Okay, and then our sig digs, well, we look at our number of moles, and the leading zeros don't count. There's 1, 2, 3 sig digs, so your final answer will be 3 sig digs, and units for mass are grams. Finally, this last question, a lot of students got wrong. Again, I'm looking for moles and I'm given mass, but there's a twist to this question, and that is that you have to actually put this into scientific notation. So here's a reminder of how to do that. Okay, so we're given grams. You get your correct formula, and read carefully, right? It's iron 3 sulfide, not sulfate or sulfite. It's the Fe3 plus ion and the S2 minus ion. So we have Fe2S3, we get our correct molar mass, and then we got to flip it. We have to put grams on the top and the bottom so they cancel. Now we're left with moles. When you do this on your calculator, you get this number 0.01986 blah, blah, blah. Well, the answer has to go into scientific notation. So you take your decimal point and you're going to move it 2 places to the left. So it's 10 to the minus 2. And then to get 3 sig digs, the 1 counts, the 9 counts, and the 6 makes that 8 round up to a 9. So your final answer is going to be 1.99 times 10 to the minus 2 moles. Okay, well, that is it, guys. You got your last assignment to do. Hopefully this feedback will stop you from repeating any of the errors you might have made. So there is molar mass on this last summative, types of reactions, writing reaction equations, predicting products, types of compounds, ionic molecular acids, bases, being able to name them, write formulas, and know their properties. Okay, good luck, everybody. Have a great rest of your day, and we'll talk later.